Hi all. So we know everyone uses Git now, but before we dive into this talk, I'm curious, who's deploying to Kubernetes? All right, okay, a healthy portion of you. And who's actually using GitOps currently? Okay, a lot less. No problem. All right, a little bit about me. My name is David Flanagan. Most people know me as Rock Road across the internet. I am currently a staff developer advocate for a company called Pulumi. Pulumi is an infrastructure as code tool that allows you to use your favorite programming language, which I'll assume is Go, to describe your infrastructure. But we also have really good support for deploying to Kubernetes through our Kubernetes provider. So I'm going to be talking about GitOps and using Pulumi to kind of make this experience better, but there will be some code at the end where we actually walk through what this looks like in practice. So you'll get to see how Pulumi, Kubernetes, and Go kind of work together. I also spend far too much of my time working on my YouTube channel called the Rock Code Academy. So if you want to learn more about cloud-native Kubernetes and everything in between, then you can just go to rockcode.live, subscribe, and there's usually 2 or 3 videos every week. Lastly, I am organizing a Kubernetes conference. So if you're not busy at the start of October, come and join us in Edinburgh. The conference is called KubeHuddle. It's on the 3rd and 4th of October in Edinburgh. So great location. It's nice to be able to walk around and see that castle staring down on you. Now, I'm going to start by saying that I really suck at naming this talk. I have tried a few different things now, starting off with calling it applying the Law of Demeter to GitOps. Is anyone familiar with the Law of Demeter? Yeah, that's fine. It's perfectly fine. So nobody knew what the talk was about then. And then I tried renaming it this year, and I was speaking at CDCon, and I called it Canonical GitOps. But of course, I've stuck to naming it again because people think I'm coming to talk about Ubuntu or some Canonical-related product, and I'm not. So I definitely need a better name, and I'm happy to take any suggestions that people have. So let's start with what is the Law of Demeter. So nobody put their hand up, so let's kind of break this down. It's old. This was a law that was first proposed in 1987. It was a research paper from a university. And the single most important message about the Law of Demeter is that we need to stop having kind of leaky abstractions and giving components, modules, packages, etc., more information than they actually need. So what we want when we write scalable distributed software is really extreme loose coupling as much as possible. So I'm sure you're familiar with that message. I don't think there's anything new there. You just maybe haven't associated it with the Law of Demeter. But it's an interesting paper to read. It also kind of spawned aspect-oriented programming, which I'm not sure people are familiar with, but it's just a nice approach to enriching functionality of existing code with new behaviors. So hopefully that's useful. Read the paper, and we're going to try and see how this applies to the GitOps pipeline. Now, if we think of traditional CI/CD systems, what happens is we store everything in Git, and then we have some sort of build or integration server that is going to compile the code, build container images, run Pulumi, run Terraform, etc. And sometimes they just push and deploy to the environment. You may have a button called deploy to prod or deploy to staging, etc. But the problem here is that we've already got a leaky abstraction, and that every time we add a new service and we write the CI/CD configuration or code for that, we have to encode all of that information about the environments into it. So that means like when you have, say, a platform team, and they want to go and deploy a new pre-production environment or something, in order for your application to run in that environment, you then have to go and subsequently update all of your repositories with this new information, or update your build pipelines, etc. And it gets tedious, especially at scale. If you are doing microservices, and if you're deploying to Kubernetes, I'm going to assume you are at this moment, then there's a lot of configuration that has to be nurtured and cared for here. And there is definitely a better way. And this is where GitOps, and why GitOps is very important. So what GitOps actually does is say, well, what we want to do with our build server is really produce an artifact, just a container image. So hopefully we're in a position where you're using, maybe it's GitHub Actions or Jenkins, GitLab CI, etc. But you can have your services provide just enough configuration to do a Docker image build, or whatever tool you're using, push that to a container registry, and that's it. That's your handoff point. Right? You don't need to know about the environments, because hopefully we're in a position where you're building a single container image and running it across all of your environments, and not building an image for staging, pre-prod, and production, which I still see quite a lot of. But hopefully you're not doing that just now. This handover point, where we push some artifact to the container registry, then means that we can have some sort of polar or syncer that runs inside of all the environments that we have. This can monitor a Git repository or some sort of OCI-compatible registry for new images with new tags or labels, or the Git code that is responsible for deploying your application. And because this runs inside of the cluster or the environment, it should actually be able to provide everything that you need to make that application work. Right. We've all heard, hopefully, of the 12-factor manifesto. This is one of the things that became really important when we started deploying with container images, because what Heroku were telling us to do is that, oh yeah, build one image, and don't load it with loads of information, but have environment variables that are passed in or available at runtime to tweak the behavior of our applications. And GitOps can and should allow us to do the exact same for our platform stuff as well. So we have the syncer, we have the polar, it pulls the repository, it's in the cluster, all the pieces are there where we can enrich that deployment. Now, another very regular question I get when I go to events is, well, how do we handle multi-environment GitOps? Like, if I have these definitions of how to deploy my application to the cluster, how do I tweak and tailor them for the different environments? Because our environments are not the same. The way that you scale your containers in production is not going to be the same way that you scale your containers in a dev or staging cluster, right? Because it's going to be much more redundant and resilient. You've maybe got a lot more traffic going through it. So we probably want to make sure that the horizontal pod autoscaler that we're using is actually much more fine or constrained within these smaller environments. Good. I think it's the Wi-Fi. Let's tether. Oh, good. I've lost a slide. Let's try and be brave and reload the page. There we go. Phew. So, with regards to multi-environment GitOps, this is an issue on the Flux CD repository. People still upvote this. That number keeps changing on the thumbs. People are still adding comments to this. So even though this issue was created in 2018 asking for documentation on how do we do multi-environment GitOps, there hasn't really been any great answers or examples produced. But when we talk about it, let's just get this image just now. We have a comment from one of the Flux CD maintainers, Michael, who strangely now works with me at Pulumi just recently. But he said, well, I'm going to create an example of this. And again, this is back in 2018, and it's a Weaveworks repository who are very much driving forward GitOps as a pattern. And they have a repository called a multi-environment example. So it sounds great. Like, show me that. And that's the repository. To this day, that landing page has absolutely nothing really of value there. So It's an evolving landscape, GitOps. It's still relatively new. We're still trying to work out how to do best practices here, but hopefully I can share some stuff with you. So, when we talk about multi-environment GitOps, and we see three major approaches right now. One of them is directory approach, which is where we have a directory with manifests for each environment that we want to deploy to. There's the branching approach, which is every time you want to have a new environment, you branch from the main branch on your GitHub repository. Or you can use a completely separate repository altogether, a repository for staging and a repository for production. And these all have trade-offs and advantages. With regards to the repository model, this works well because you can have very strong authentication on who can actually access the repository. So environments where maybe it's banking or other enterprise-style environments, this might just be a security mandate that you need to do it this way. But it's very difficult to handle drift in these environments. As your configurations change in dev, staging, and production, it's very difficult to actually be able to promote those changes because we have this hard divide about where all the configuration lives. We also have the branching model, which I like. It allows us to do promotion via pull request, which is good, right? We're all familiar with open and pull requests. We understand what's going to happen here. We can get very good diffs and see the changes from before and after. It can be a little bit difficult to do automated promotion, and by that I just mean, do you allow, it depends on where you land on am I happy with a machine to commit to my repository? I lean against that because I like commits to come from people, but of course automation still has a place. So I don't know, I've changed my mind on that one quite a lot. And drift can still be an issue, especially if you get very large diffs, so you're making large changes across your infrastructure. Things can get messy just because it's Git. And then of course we've got the ability to rebase across our branches and then trying to push that back up to another branch. Yeah, all those regular Git issues become GitOps problems with branches. And then the directory one is kind of what's winning right now. This is what pretty much every tool out there encourages you to do. So we can still do a promotion via pull request, and all of the existing tooling does this. So you might think, well, maybe this is just the best way to do it. But then we do lose that authentication boundary, and anyone with access to the branch and the repository can also see all the code, but also push changes and make changes to the code or open pull requests and stuff. So very much pick the one that fits where you are and what you need to do. Yep. And the tools, like, if you look at FluxCD, if you look at Customize, if you look at Argo, the directory approach is just the default implementation here. And we're seeing the use of overlays is probably the biggest driver here, where we have a base layer configuration for our deployments, our stateful sets, our config maps, etc. And then we have some functions or overlays that run on top of that and change them to build new YAML files for the environment that we wish to deploy to. Yeah, Customize is probably the biggest driver here. Although Helm does this, but it's a bit weirder with Helm in that we have a values file, and I see a lot of people doing a values file for each environment. And values files can get very big as well, so there's loads of challenges there. But overlays, to me, feel like we're just dismissing that law of Demeter, because again, we're pushing all this environmental information down into this set of tooling, or each service. And we want to avoid that. Again, we have the platform concept, which has all of this information. So when you spin up a new environment, you are actually telling it the size of the cluster, the Kubernetes version that you need, the tools that need to be available, and likely you're creating DNS records. So all of that information needs to be propagated through. And I tried to make this kind of comparison that thinking of overlays is kind of like inheritance, and we're kind of, I feel like as a developer industry, we're moving away from that, and we're looking at more composable solutions. So let's just try and avoid overlays whenever possible. So we want less coupling. So we really don't want our applications to have any of these. So what is the alternative? And of course, yeah, the 12-factor app stuff here is just like super important. I wouldn't ask anyone to kind of say if they're building images per environment, but if you are, maybe that's something that you have to address. We really want to be in a landscape where we have a single image pushed to a registry and it runs everywhere. And if you're not familiar with the 12-factor manifesto, I think it's available at 12factor.net. And it's just like 12 rules about how to build applications and increase your velocity without kind of having too much coupling to the infrastructure that you're running on top of. Okay, so what is the solution that we want to kind of take a look at today? Well, we only want one description of how to deploy our application, and that means removing that overlay approach. We just want to define that our application runs as a deployment. We just want to specify that it has some sort of horizontal pod autoscaler that can be configured based on the environment. If there's ingress, we need to be able to configure that, and this is where things get very tricky. Because the ingress manifests themselves do have to have the actual domain information in it, or they do not work. So how can we actually modify that in the cluster is a very big challenge right now. There are a couple of routes, and we'll talk about them in just a moment. We're also seeing a push in the industry for platform engineering. I think SRE is kind of evolving towards this concept where we've realized that DevOps was great. We gave developers all this tooling where they can work with the cloud and deploy their own infrastructure. But of course, building a platform is a lot more than that. With a platform, we have to put guardrails in place that stop people being able to make silly mistakes, or you could essentially bankrupt an entire company by getting the auto-scaling configuration wrong without any caps on it. So these things all require actual teams, platform teams, to provide the platform. But in doing that, you also have to provide a divide. Like your application developers must be able to be onboarded to that platform as quickly as possible, so that they can bring on new services and new applications whenever they need to without having to directly work or demand time from the platform engineering team themselves. So when we break into that divide, and we've got a demo of this, this all becomes possible via something like a shared contract. The contract being that the platform team will provide this information, your application can consume it and tailor the way that it runs, which sounds a little abstract right now, but hopefully the demo will help cement that. The most important resources to get this right when you're doing GitOps, at least with a single definition, is of course the ingress. Those domain names are the most important one. The HPA has to be tweaked. Again, what we do with scale and staging is not the same as production. And of course, we have secrets. We have lots and lots of secrets in our applications and platforms these days. Like we speak to other services. We might want to be speaking to HashiCorp Vault, for instance, and we need a way to be able to do that within the cluster and not hard coding anything. So there's just all these things that Kubernetes solves a lot of things for us, but the patterns that we use to deploy them are not quite there yet. Okay, so I'm going to do a demo of using Pulumi as a platform provider and then show you how to be a platform consumer. However, there are alternatives to doing this. You can use Kyverno. Kyverno is a mutating admission controller that runs inside of your Kubernetes clusters. And what it allows you to do is to say whenever an ingress object comes in, maybe we want to modify that in some way. This means you can have placeholders inside of your Kubernetes YAML. Kyverno will detect them, and it will actually look up a config map value and drop it in for you. It's very complicated. Trying to describe that entire workflow or pipeline in YAML is not great. So I do like Kyverno, but I think in this particular case, it's not a great fit. What I am seeing a lot of teams doing is going down the custom operator route. And this is actually a really good approach as well. Why not just write your own environmental operator that understands the shared contract that your development and platform teams have, and have it do the mutation on entry. The benefit to that approach is you can use Go. You can just write your own controller with your own logic and then ship it, and it kind of works. All right, let's take a look. So let's pull up main. There we go. So this is a very simple Pulumi program. Now, this is supposed to be my platform code. Obviously, it's very simple right now. I'm using a cluster that just exists on my machine, so I'm not creating the cluster. I'm not creating DNS records. But you could imagine this is where you would keep all of your Pulumi code to do those jobs. Once you've done all those jobs and the platform exists, is that you have to make it easy for your teams to come onboarded. Onboarding a team here is just me providing a function. So a pull request from a development team would be them copying and paste this and making a little bit of changes. Now, you can go very strict on that contract between the development team and the platform team with this kind of, I'm using a map. But that could be a real type that you share in a common repository and consume it as a package and just say this is what all of our applications need to be able to run. But for this demo, I'm just kind of throwing it together. This kind of implicit contract also means that the application teams can, again, via a pull request, make changes to that contract on their own side without having to work with the platform team. So if I want to come in and say, well, we now need a max scale, I can do what I want. So there's definitely trade-offs, and pick whatever works for you. But the most important thing here is that we do have something called onboard team that allows us to get a team onto the platform. Now, what does that look like? Well, there's quite a lot of Pulumi code. What we're doing here is deploying one Pulumi Kubernetes operator for each team that is onboarded into our cluster. This allows us to kind of really fine-grain the RBAC and the permissions that we give each team as well, which is really cool. So you can see here that we apply some custom resource definitions. We deploy a new service account. We have a role, which is a little bit big. Of course, this might seem a bit scary to people that are familiar with Kubernetes because there's a lot of permissions here. But when you're using GitOps, this is a challenge that hasn't been solved yet either, is that if you want to be able to deploy anything to a Kubernetes cluster, you have to give it the permissions to deploy anything to a Kubernetes cluster. So you do kind of end up with this root-like controller, but it is namespaced at least. So if we scroll past the role, we have a role binding. So just attach these things together. And then we've got the deployment. So I'll just run through this in a little bit of detail, just because if you're not familiar with Pulumi and how this works, it might be quite interesting. But Pulumi actually works off of the open API specifications from the Kubernetes project and from any custom Kubernetes operator or custom resource definition. And this is really, really cool. So we can actually just work with the native APIs from Kubernetes. Here we're using apps v1, and we can just say new deployment. This is all typed all the way down, so I'm able to take advantage of VS Code, my language server, and my autocomplete, so that I can mostly tab my way through the creation of pretty much every single Kubernetes resource, which is very nice. That's not something that is easily accessible in YAML, although the support is getting a bit better there. But there is one small challenge that people stumble with when using Pulumi to deploy to their Kubernetes cluster, and that is that all primitive types are actually wrapped in Pulumi types. This is something that we're investigating removing, potentially using generics, but we're still very early in that kind of thought process and discovery process. So you will see Pulumi ints, Pulumi strings, Pulumi bools. They're a necessity for now, but hopefully we can fix that. Now we've got kind of the selector, they've got the template, we've got the spec, and then we're just throwing the image. So we just tell it we want this operator. And we have one more custom resource, and I'll come back to the config map in a second. So we have this custom resource at the bottom. So once we've deployed this operator, it defines a custom resource called a stack, and we can deploy a stack to a cluster. This is what sets up that polar or sinker. So you'll see here that we have a Pulumi, it's a stack, we give it some metadata, which is just a name, and then we have this kind of block of configuration here. The stack is really just a name. It only lives within the cluster, so it's not particularly important. I am using a Pulumi access token, but you can store the state 100% in the cluster. The nice thing about doing that instead is that when you shut down the cluster, the state just goes with it. So as long as everything is contained. However, if you want to use Pulumi with anything external to the cluster, you're always going to want to use like blob storage for the state, or perhaps the Pulumi service, which is free for developers. These are the two most important parts of what we have in the stack definition. One is that we have to point it to some repository. So we say, OK, we pass this through in the onboard team bit, but we just have this value called repository. I've pushed something to GitHub just called GopherCon, and I'll show you that in just a moment. From there, we have to provide a branch reference. So we're just saying here, deploy the main branch. And then there's some magic stuff that just makes this experience a little bit better. Continue on resync just means that even if the commit hasn't changed, every 4 minutes or whatever you configure, rerun the entire Pulumi program. This is how you get drift detection, which is really important when you're working in a GitOps environment as well. If you've got a little bit trigger-happy developers that are running kube control commands against your cluster, which hopefully we're not doing, then you want to make sure that that drift is caught very quickly. So if people make changes, you want to force them or push them towards going through the GitOps methodology. Otherwise, things just start to break down. The refresh is what allows the drift detection to work a little bit better. So Pulumi does work against the state file traditionally. However, in a Kubernetes environment, what we want to say is just actually go speak to the cluster and make sure what we have in our state file is actually accurate, again, improving the drift experience. The last two things here is just I'm setting a resync interval of 60 seconds. This is purely just for today, so that when I do push a change, we see it a little bit quicker. And then we have destroy on finalize. Again, if I do a kube control delete on a stack, it will delete all the resources that it creates. So it does apply finalizers. If anyone hates finalizers, I'm with you on it, but they are very useful in this kind of context. Now we have the contract that we defined. So this is our platform team. We've onboarded a team. We're creating a namespace. We're creating an operator, and we're deploying our stack. We've got two options here. So there's one option where we can go down all Pulumi all the way through. But if you want to be able to use another tool inside of the cluster, like Argo CD or Flux, then it may be that you want to push a config map into the cluster with that contract. Mine is hard-coded for right now, but you can see that we could just pull in that value that I'm using above in the onboard function signature. The all Pulumi way is just to pass in the config here. So this actually sets the configuration on the stack, but it's only available to Pulumi at this point, so that's just a decision that you have to make on whether you do plan on bringing in other tools for a portion of your GitOps pipeline. And let's just take a look at our main.go one more time. Our signature, our contract here is that we have a domain name, a port, a minimum scale parameter, and a maximum scale parameter. That's it. That's just enough, hopefully, where we can show everything working. Now, if I go to the application repository, we have a very simple Pulumi program as well. So this is what application teams would be writing with and working with. Now, it's usually best to keep this deployment logic next to your own service code. Just have a deploy directory or a Pulumi directory or whatever, and stick it all in there, because you want to be able to make it easy for people to modify their application and how it gets deployed at the same time. Try and avoid keeping these separated as much as possible. Now, for the Pulumi approach, we can just say that we have some sort of config that we expect to be available on the stack, and here I'm just pulling out the minimum scale value. And this is just actually going to be set on our deployment, which is, in this case, a very simple Nginx demo. Something that's also very cool here is that we can actually speak to the Kubernetes API from within the cluster. So Pulumi has native support for everything in client Go within Kubernetes. So I can actually just say, hey, go get this config map. And I could actually deserialize that to some sort of type struct. Now, I have duplicated this across both projects, but we would probably try and share that contract in a better way. But it's just a really nice approach that we can reach out to the API, pull a config map, pull some secrets. If you really wanted to, you could speak to DynamoDB or some managed database or a Postgres, like whatever. Like, you then get to define how all these components interact. But we are applying the Law of Demeter as best as we can here. For this demo, I've just thrown the minimum scale into the replicas here. You can imagine if this was an ingress object, it's me dropping in the API domain. If it's the HPA object, I'm going to be configuring the min, max, and scale, and potentially the triggers. If you're setting up monitoring within your cluster, there's a whole bunch of things that also need to change there. So let's make a small change to this. So here I'm going to set the minimum scale to 4. And I'll run get pods. So what we have running in this cluster is my app depth deployment, which has a replica of 2 because the minimum scale was originally 2. On the platform side, you can do GitOps on the platform side, but it's usually best to do traditional CI/CD pipelines here because upgrading clusters is not a trivial task. And your platform is always responsible for the cluster, although it isn't in this particular example. So you'll probably find that a CI/CD process would run this kind of Pulumi up. So it tells us that it has to make a change. We can click on details to see a bit more. Yep, we can see, OK, it's now going to change minimum scale from 2 to 4, and we can hit apply. It'll just take a wee moment. And last, we'll do one more change. So this will actually reconcile in our cluster for us. We could leave that running. Oh no, I've got, doesn't matter. And if we come across this deployment and say that we actually don't want to run Nginx anymore, let's just say HTTPD, which I think should be okay. And I'm going to commit this one. So now I've got main.go, and this local file that I'll talk about in just a moment, but we can say commit fix new image, worst commit message ever. But we pushed this. So our platform team, we modified the contract and we ran a Pulumi up. That's going to make a change inside of our cluster. In fact, we can now see these pods. They might not run because my local cluster is not exactly, it's not got a lot of resources. But if we take that watch off and run it again, you'll see that the scale has went from 2 to 4, and that's just fine. However, as an application developer, we made one more change. And this repository, I'll show you at the end. The repository is available at github.com/rawcode/gophercon. But it's just that Go code, and we changed the image. So if we actually run a kubectl watch again, what we'll see is the operator is going to detect that that Git repository changed, and then apply all of those changes for us. And we can run the logs on that operator too. So. In fact, you can see there we've got stuff that happened 2 seconds ago. So our operator is spitting out the things. You can see here that it's saying our deployment app dep is being updated, and in fact, it's just finished. We can see lots of container changes here, and if we run pods, get pods one more time, we actually do have 4 running pods, so it did work. And if we describe pod, and we should see the image is now HTTPD. So this is kind of a full end-to-end workflow of how you do the platform side using Pulumi Go, traditional CI/CD. It already has access to all of that information about domains and such because it's responsible for setting up the DNS record. It's responsible for configuring the Kubernetes cluster, adding the nodes. Then you've got the onboarding option that you provide to your developer teams. It can be as simple as a function. It could be, you could just give them a YAML interface that you process in parse within the platform so that it's even easier for them to add. Again, depends if your developer teams are all working in Go or maybe they're using TypeScript and they just want to do something in YAML. That all comes down to you. The operator runs in a cluster, it pulls their changes and applies. The question that I normally get after that is, well, what about local? So because we have this concept of a contract, we can actually just set that in a local stack inside of our Pulumi program. So you could just CD into that Pulumi or deploy directory. You can modify this contract whenever you want because it's local only to you. And you can run a Pulumi up against some local cluster if you want, and you get the exact same experience. You don't need to tweak anything else within the setup. So you get a really good development experience locally and a fantastic GitOps experience in production too. So that was the Pulumi demo. I'm not doing a Kibana one. I do have the YAML. I'll share that in a tweet after this talk. And the custom operator is also very good. But hopefully what you've seen with the Pulumi demo is that you can use Go, which is a good programming language, to describe all these resources and enrich it with access to config maps or Pulumi stack configurations. Now, final tips. Building this contract is not easy. My example was very trivial. But you really need to understand the variance across your environments. So if you take a look at how you provision your environments today, how you're deploying, just even running like git diffs or diff on files, seeing where those changes are and try to bring them all down and provide that shared contract can take a little bit of time, but it is the most important thing that you have to do to be able to have that kind of canonical representation of how do I deploy my application. There were no overlays. Let's try and avoid that as much as possible. Something that I don't have in the demo here is that we also have our environments provide a lot of random seeds and hashes and such like that. Pulumi has a really cool random provider. If you've got your platform or your application code creating a new database with a user and a password, that's not part of your contract. Those can actually just be inferred within the environment. So just use them as random strings as much as possible, and then don't worry about bringing that into your contract process. And the HPA, people love it, people hate it. But it's so important when it comes to this one representation of deployment application. You should never, and that's quite a bold statement, but probably never set the replicas on a deployment full stop. It's not going to work the way you want, especially in a GitOps environment, so always make sure you get comfortable with the HPA. And that HPA could just be that I want one and only ever one, and that's fine, but never put that replicas into your deployment. Okay, so which one? Huh, that was supposed to be much earlier. The branch model is now an option, which is good. So if we have this canonical representation and we have that contract, we can actually do promotion with a pull request now without it getting too complicated, which means when you build new images, you can just update the tag and promote it via pull request. And because we now have trust that everything else comes within the cluster, so I'm probably leaning more towards the branching model these days, especially now that we can do it with no overlays. And it also makes environmental or ephemeral environments a lot easier too, because branches are relatively lightweight. We can create new ones and we can delete them just as quickly. So yeah, I'm definitely 100% leaning down the branch model now.